Right, good afternoon. Can everybody hear me? Can you please send just a yes or a thumbs up in the chat if you can hear my microphone? Oh, thank you, Kylie. Right, I shall start the live stream also now. Okay, and I should be live. Right, can everybody see my live stream? Let me just start. Where is that now? Sorry, I should have set this up a second ago. All right. Thank you. Okay, and you can see. Just a quick recap. On the left side, on the text channels, you'll see on the left side when you look on my screen, we have the separate text channels, the general lecture material, coding assistance, technical assistance, Wednesday questions, and Friday classes. All communication during the class will be in the Friday classes. That's also where I'll be sharing some code and some, if there's any work I give you during the class, like last week, the assignment, the test. I also posted it in the Friday classes channel. And then afterwards, all the lecture material will be available on the lecture material text channel. Then you'll see here is the PowerPoints, the PowerPoints as well as the YouTube videos. For last week's class, there was not a YouTube video. I started recording and realized a few minutes in that it is mostly just the test. I didn't give any new information. All right, so let's get into it. I'll first be taking a look at the test we did last week, question 2 and question 3 that we couldn't get to. How was round 1, the one we did during the class? Could you do question 2? Do you remember question 2? I'll ask you to write a program that asks for a positive integer of a value n, and then calculate all the factors of that n. How was that one? Do you remember that question? It was easy. All right, it was easy. Could everybody get that working? Was it difficult for some? I'll get to this one now. Sorry. Right. Let me take a quick look at this one and explain what I did here. All right. Kylie got it working. That's awesome. If you did not get it working, then it is no problem. It just takes practice. Oh, I just quickly want to mention, I saw on the Wednesday channel that some students find it a bit difficult to keep up with the classes. I want to say that we have completed most of the curriculum that I wanted to do with you. Today we'll be looking at 2 quick new functions, but they're very small, very fast to do. But then I believe you should have all the tools you need to complete an Olympiad programming test. So what I want to do is I want to review some of the work. So I want you to, during the course of this week, email me. I will put up my email again in the text channel. Let me quickly do that now. I will put up my email here in the Friday classes channel, as well as in the general channel. And then you can email me topics you struggle with. Go take a look at our lecture material, everything we've done up until this point. And I want you to send me an email about concepts you struggle with, and I will review that in our next class and do some more examples on those. Try and send your emails to me by about Wednesday, so I can set up the class on Thursday, and then we can review them on Friday. All right, so anything you struggle with, please feel free to tell me. All right, so let's start with this one. Okay, so this question, I ask you to write a program that asks for a positive integer value of n and then calculate all the factors of n, excluding itself, and add them together to give the answer. Okay, so for example, if we look at 8, then 1 goes into 8, 2 goes into 8, and 4 goes into 8. So then we go 1 plus 2 plus 4 equals 7. All right. So everything that can divide into the number n, so 8 being our n, and then we output the sum. Okay, so my algorithm here is I ask the user for an input. So using the int, I cast our input to an integer, and I store that in the variable n. Okay, so then I create a variable for where I sum the factor. So I keep that at 0. Okay, and then for I in range 1, we start at 1, and then we go up until n divided by 2. All right, why do we not go up until n? Why don't we go up until n? Well, let's quickly take a calculator, so I just can quickly show. So 8 divided by 1, 8, okay, we can do that. So let's say 8 divided by 2, yes, that works. Then we can go 8 divided by 3, yes, Kaylee, it is unnecessary. Okay, so 2 doesn't go into, so we can say 8 divided until 4, yes, 4 can go there in twice. But then after that, every number bigger than half that integer will not go into that integer. 5 does not go into 8. 6 doesn't go into 8. 7 doesn't go into 8. And 8, once again, we can ignore because we do not add that to our factor. Alright, so yes, as you said, it is unnecessary. So we save computing power. This makes our algorithm run a lot faster with big numbers. Okay, so then if that number does not give a 0 when divided into our n, if we use the modulus. Remember, the modulus shows the remainder. So if the remainder is 0 when we divide by that number, that means that number is a factor. So if we divide, for example, 4 into 8, and we get a 0 as a remainder, then obviously 4 divides perfectly into 8 with no remainder. So then we add that to our factor. So then we use the plus equal, so meaning we add I, where I is currently. So at that point, for example, it would be at 4. Then we add 4 to our factor. And then we just output our sum. Right. Not so difficult, this one. Number 3 was a bit more difficult. So number 3, I asked you to create an encryption algorithm. So each letter ends up n letters to the right. Okay. So the user should input a word and then input a number, and that number means all the letters get shifted. Okay, so if you shift the word apple by 2, then it becomes L-E-A-P-P. So what that means is we take the letter A, and we shift that letter 2 times. So then A ends up where the P is. The second P ends up where the L is, and so forth. And then when a letter is at the end of the word, that letter goes back to the start. It goes to so the E would go to the A's place and then to the P's place. So then it means the entire word becomes L-E-A-P-P instead of A-P-P-L-E. All right. And then if you replace the letters 2 places further in the alphabet, so then what you do, so after the words have been, after each character has been shifted n amount, then you shift the letters themselves n amount. So that means we take the L and we go L, M, N. N is the second letter from L. E, we go E, F, G. G is the second letter from E. So then the whole word becomes N, G, C, R, R. All right. So you understand, so there's 2 parts to this algorithm that we have to create. The first part is shifting the single letter, and the second part is shifting the alphabet letter to n spaces. Right. So let me show you what first question, how was this question for everybody? Did some of you find it easy? I actually struggled a bit with this one. It took me a while to get it right. How did you find it? Doable. Doable. Yes, that's a good way of saying it. It's possible, but it bit more difficult. Okay. So let me show you the official solution also for this one that I adapted a bit. So first we take the word. as an input from the user. So the user gives us the word, for example, apple. And then we ask the user how many spaces do we want to move that word, right? So now, the first part of the algorithm being split into two, first I shift the word. Okay, so I create a variable called new word. So as I explained in the algorithm here, we start at the letter A, and then we want to shift A to n spaces to the right. So I'm just going to use this first example where I say 2. So just imagine now word being A, apple, and n being 2. All right. So we want to shift each letter 2 spaces to the right. So what we do is for every letter in the range, for every I in our word. So for the length of the word, that is going to be our range. We're going to be taking this word, this new word, setting it equal to a new word. So currently, when we start, it is an empty string. All right. So then we take this empty string and we add our current word and then the index. So you'll remember the square brackets on a string means the index. So what index we start at? So we take the I where we currently are. So we're now currently at 0. And then we 0 plus the length of the word. So the length of the word is apple. How many letters is that? That's 5 letters. A-P-P-L-E. Yeah, 5 letters minus n. So minus 2. Okay, so that's where we start. So then that means our first letter will, so the first number in this bracket will be 3. And then the modulus by the length of the word. All right, so the length of the word being 5, so 3 remains. So that means we start at index 3. Okay, so this entire bracket will, for the first iteration, will be 3. So that means the third letter in apple will be 1, 2, 3. That means it is that. All right, so then apple will move 2 spaces up. All right, it will go to index 3. So that's index 0, index 1, index 2. Because it is 0 based, we start counting at 0. Right. And then we do that for every single word. So let's actually take a quick look how this works. I'm going to be using a breakpoint encryption. Right. So I'll be adding our breakpoint just there at the start. We will debug to make a bit more sense of this. Okay. So let's start with the word apple. Right. The audio is a little broken up. Give me a second. Let me just move my router. Sorry, it is a problem that happens now and then. I am aware of it. Sometimes my router struggles a bit to catch up to my computer, as it is a bit far away, and then the noise gets, the sound gets a bit broken up. All right, I hope it is better now. But I am aware of it happening. Okay, so let's take a look. So you'll remember, as I explained in one of the previous lessons, if you put in a, you can click on the left side between the line number and the program itself, and you can add a breakpoint. We can use this for debugging, for explaining our code. All right, so let's take a look. So first I enter the word. Okay, so you'll see the first input will be our word, which will be apple. And then the second input will be the number we want to shift it by. So let's shift it by 2 as the example. All right. So let's take a look at what happens. So we have our string, new word, currently an empty string. And then for I in range. So now you can see, you'll see here in light gray, next to each line, PyCharm tells us what that value currently assigned to the variable is. So you'll see up until this point, we have apple assigned to word, we have 2 assigned to n, and we have an empty string assigned to new word. Okay, so let's see what happens now. And here on the bottom, this might be a bit small. I can't find a way to increase the size of my debugger, unfortunately. I hope you can see this. Okay, so here you can also see what each variable is currently assigned. Okay, so let's start. Let's step into this code. So we take a step down. The highlighted line is where the program is currently running. So now we assign, you'll see after running this entire calculation, it assigns new word a new character. So the first character assigned to new word is L, right? We run that again. E, A, P, P. Right. So there we have the first part done. We have this first part. If you shift the word apple by N2, then it becomes L-E-A-P-P. Right. So that is done. Now we go into the second part of our algorithm. We want to replace the letters 2 places further in the alphabet. Okay, so now here's my second part. So I want to shift the characters. So the code moves down because we have completed the entire word. So our first for loop has completed. Right. So now we assign 2 variables. So we have our word. We have our word, the original word, which is still apple, and we have our new word. So now we assign our old word, which is apple, we assign that the new word. So now it becomes L-E-A-P-P. So this first one is now L-E-A-P-P. And the new word is once again an empty string. So we start basically the same as here from the beginning, but we just assigned this whole first algorithm's result to the old word, which was just apple. Right, so now as you can see at the top, word is no longer apple, it is now leap. Okay, so we start now with the second part. So for every I in the range of our words, the length of our word, so that means this will repeat 5 times. Now we do this little calculation. So we take new word, we assign to it new word, which is currently an empty string, plus, okay, so I will explain these 2 functions now properly. Let me just quickly say it gives you this gives you the Unicode result. The first one gives you the number, the integer number, and the CHR gives you the character. All right, I will explain that properly in a bit. It will make more sense, and then we can come back to this. So I run this line over here. This is a short calculation to take every character and move it up 1. All right. So let me quickly show you the difference between CHR and ORD. So that line makes a bit more sense. Okay. So the CHR function, it returns the character that represents the Unicode of that number. Okay. So for example, if you pass a 97 into the argument of CHR, then it returns an A. So you'll see if we take the variable X, we assign 97 to the character function, and we then print X. Then we get the result of A. And the opposite way around, vice versa, if for the ORD function, it is the opposite of the CHR function. It returns the integer value of that character that is passed as an argument. Okay, so if we pass H to ORD, then we get the value of 104. Okay, so what does this mean? So there's a Unicode table. Let me actually just show you this on the internet. And of course, Firefox wants to update now. So every character is assigned a number value. So 104, for example, 104 is H. All right. You can take a look at this Unicode table. I will share the link with you now. Once Firefox is updated, then I'll share it in the Discord chat. All right. So every value you'll see starting from the top, the null is assigned to 0, all the way to the bottom. I can't remember what this number is now. Let's take a quick look. Unicode table. Unicode table. This one. Just the first one anyone will work fine. So then you can hover over the code. Let's take a look at the capital E, and then you'll see there decimal is 69. If we go to D, decimal 68. The H the DEC 104. You'll see that 104 represents the character H. Okay, so that is the Unicode table. So every character, every possible character that the computer can print is assigned a Unicode value. Right. So this is our CHR and ORD function. It is just to convert from the Unicode or to a character, or vice versa, from a character to a Unicode. All right. So that is what I do here. So I want to get the number value. Okay. So I do this line so that I can see the Unicode value of our current letter. So for example, if the letter is A, then our Unicode value will be, let me take a look here. So for capital A, our Unicode value will be 65. So what I want to do is I convert to a Unicode character, and then I want to add to. So then I go 65, 66, 67. All right. So then I take 67 and I return that. So that means we take this letter and we move it 2 spaces to the right. And then once I return this letter, that is how we shift the individual alphabet letters. Okay. You'll see also I use a by modulus 26. That is, there's 26 letters in the alphabet. So what I'm doing here is, if we get to the end, so I take so I start at A. Starting at the letter A, the Unicode value for that will be 65. 65 up until 90. So then once we get to 90, I do not want to move over to the other symbols or lowercase letters. So what I do then is I use the modulus operator to go back to the start from A. So if a letter gets shifted past this range, then it will shift back. So that is how we shift the individual characters. All right. So I'm going to show you a quick debugging method, something I do sometimes if code doesn't make sense to me, or if I struggle. What I'll do is I'll take all the parts individually. So I'll create a new variable. Let's just call this test var1. What I do then is I take a piece of code that I find difficult to understand, and I'll just use that in the debugging. So let's break this up. So let's say I just want to understand what this value will be. So I'll say equals that value. Let's even break it down further. I'll take away this. Then I'll say test var2 equals, then I go test var1 plus, and then I take the second part of the code. And then let's say test var3. And then I take the final piece of the code. All right, so then I say test var2, and then with that line of code. So then I add a breakpoint here. So we do the same word again, apple, and shift it by 2 spaces. All right. So now I can see what will happen, what will be the result of this. So now we're first taking a look at what is going to be the result of this first part up until just before the n gets added. All right. So then we see once that calculation has been done, then we get the results of 11. After the second part, we get the results of 13. After that part, we get the result of 78. So 78 will be the Unicode value returned. So then we can take a look. 78, where is that going to be? Around year N78. All right. Now I can see how we get the value. Okay. So you can take my code that I post on PowerPoint, and you can be creative. Try and break up every line into separate lines to see what every separate line does. It makes a line like this a lot more understandable. So that is what I do to make sense of code that I struggle with. Right, so and then at the end you can just remove that because it is not necessary. It is just to help you understand. Alright, we can do this line for line as well, but keeping everything in a single line. If you can make your code run, if you can shorten up your code, that is always useful for less lines. But if it is difficult to understand, then rather break it down into separate steps. Okay, so that is what I usually do when I struggle with a program. I break every part up into separate smaller steps. Alright, so that is my solution. Now let's take a look at the homework. Okay, so today's lesson will be a lot more focused on your homework. I just want to make a quick note here. If you struggled with this, don't get demotivated. I've been programming a few years now, and I found round 2 for 2016 insanely difficult. I had to ask some of my friends how to do it. I went online for solutions. Usually the time limit is about an hour for these Olympiads. But I spent, I think, around 6 or 7 hours completing this one. So if you struggled, please don't feel bad. I had a very difficult time completing, especially question 2. Question 2 looked very easy from the get-go. And once I started, I realized I am really struggling with this one. So don't get demotivated. It just takes practice. But eventually, it should start making sense in hours, maybe even weeks, months. But don't give up. All right. It took me a long while. So let's start with number 1. All right. How was number 1 for you? Anybody that struggled with number 1 or found it easy that wants to share? How was it? Challenging yet fun. Yes, I actually also enjoyed number 1. That was a quick, fun little program for me to write. Okay, so number 1 is the palindromic sum. Okay, so what is a palindrome? Okay, so let me quickly explain. A palindrome is where it is the exact... if you reverse the number, it will be... not quick for me though. That is absolutely fine. Number 2 and number 3 took hours for me. Absolutely hours. But if you enjoyed it, I'm very glad. All right. And if you solved it, even better. Okay, so a palindrome is where the left side is equal to the left side is a mirror of the right side. For example, 3, 8, the mirror of that is 8, 3. Okay, so that is a palindrome. Okay, so adding any natural number to its reverse and repeating the operation with the resulting sum will, in nearly all cases, eventually give a palindromic sum. Okay, so a palindromic number is a number which reads the same from right to left or left to right. For example, 3 to 3 is a palindrome because if you start from the left side, you can look 3 to 3, and the opposite way, it'll be 3 to 3. While 3 to 1 is not, because 3 to 1 is not the same as 1 to 3. Okay, so we want to create a program where we see how many steps it takes to get another palindrome number. Okay, so for example, if we take the number 38 and we reverse that, 38 plus 83, then we get 121. So that is a palindromic number. Okay, so that means for 38, it only takes a single step. So taking the number 69, for example, this will require more steps because 69 plus the reverse of that, 96, is equal to 165, which is not a palindrome, all right? Then we take this result, so we take 165 and we plus it with its reverse, which is 561. That 76 that is also not a palindrome. So and we repeat that step, and that is not a palindrome. And here we get the palindrome. So what we did now was it took 4 steps. So immediately I saw there, okay, we're going to need a loop and we're going to need a counter. Okay, so let me show you my solution. So first I started with a variable called number, which is the input from the user. Then I have a bool, so a bool value. So either it can be true or it can be false. Okay, so this will be my flag. So I'm calling this is palindrome, and I'm setting it to false. And I'm setting up my count, which is 0. So now I start from the beginning. So now I do a not. So I start with doing a loop, but I'm checking while it is not a palindrome. So while not is palindrome, so this means while is palindrome is false, this loop will run. The moment we will set this to true, this loop will cease. It will exit. Okay, So I have a palindrome sum, which is a new integer I'm creating, a new variable, and then I take our number. And you remember in the previous class we did the index minus 1. So what happens when I take any string or number or anything and I reverse it? Or I use this colon colon minus 1. I actually gave away the answer now. But what will this line of code do? So let's say, for example, I input 38. What will this line do? Let's see. Reverse. Yes, Keen. There you go. All right. So we reverse. So that means if I input the number 38, then in this line we will take 38 plus the reverse of 38, so 83. And then we add 1 to our count. Okay. Now I do a check to see if it is a palindrome. So first I take the palindrome sum. So I say if I convert it to a string, and I say if this palindrome sum is equal to the same string, so also if it is equal to palindrome sum but in reverse, that means we have a palindrome. All right. So if it is true, then our while loop will exit and we will print the result. But if it is not true, then we set the number, the new number, we set to the sum of the palindrome. So if this is not true, then we will set the number to the result. So if we enter 69, we will set the number to 165, and we will repeat that entire loop again. And then if we get to this step and it is not a palindrome, we take this new result and we input it into number, which is on this side, and we repeat the entire process until we get to a point where the palindrome sum is equal to the reverse of the palindrome sum. And that is how we know we got the palindrome. And then we just print the count. So the count is the number of steps it took to get our palindrome. Right. Number 2. This question I did not enjoy at all. Is there someone who enjoyed this question? Could anybody get it working? I got mine working, but through a lot of tears and effort. Anyone who got this number 2 to work? Who found it easy? I believe there are some students who would have found it easy. I did not try hard enough to get it to work. I felt close to giving up a few times. Right. So let's take a look. All right. So I'm going to break this program down into steps. So as I explained also in the previous solutions we did now at the start, if a line of code doesn't make sense to you, I want you to input your own test variables to see what a line of code does. Break the lines of code down into smaller steps. I did not have enough time to complete it. Me neither. And yet I just sat and tried to get it done. More out of frustration than actually wanting to solve it in the end. Yes, number 2 was quite difficult. All right. So let me explain what I did with number 2. So I started by creating a function called repeating decimal to handle some exceptions. Okay, so first I check if the numerator is 0, then return 0. So that means if the top part is 0, then we don't even have to carry on. The program can just terminate. All right. If the remainder is 0, directly return the result of the division. That means we do not have a... Thank you, Kylie. I doubt that. I was quite frustrated by the end. So if the remainder is 0, then we directly return the result of that division. So then there is no remainder, so also there's no need for the program to execute. Okay, so here we start. If the numerator is 0, just return 0, then we can exit this. Otherwise, if the numerator, the remainder is 0, the numerator divided by the denominator, then we also will not have a remainder. Okay, easy enough. So now what I do, this line of code, the abs and then an argument. Let me quickly show you. So let's go Python abs. Okay, so this gives us the absolute value. Okay, so it returns the absolute value of a number. So the absolute value, let me quickly show you if we run this line of code. So the absolute value, if it is a negative, it will convert it for us to the absolute value, which will be a positive number. All right. So that just means basically we ignore negatives. Okay. Now let's carry on. Where was question 2? All right. You'll see my question 2 is quite long. Where were we now? Okay. So first I get the absolute value for both the numerator and the denominator. Okay, now we store our output for all the digits before the decimal point. So we concatenate the quotient of the numerator and denominator in a string called result. So what that means is I first want to get the left side before the decimal. So I first want to store in a string everything on the left side of the decimal. So I create an empty string, and then I add so you'll remember floor division, if you use 2 division divide by symbols, then we just take the whole integer and we throw away everything after the decimal. We throw away the float. Okay, so that is because we'll be calculating the float on our own separately later. First, I just want the whole integer, and then we add the decimal point. Okay, so if you take, for example, the number 8 divided by 8, then this will just okay, well, 8 divided by 8 will not run up until this point. So let's say if we take, for example, 10 divided by 8, then on the left side we will just store 1, and then we will add the decimal point on our own. Okay, so now we want to start keeping track of every new numerator and quotient after the decimal point. Okay, so you remember in this long division we did. So now we're looking for quotient and numerator combinations. Okay, so what I mean there is if you take, for example, if you divide 1 by 3 using this method, then you'll get the you'll see this combination repeat, the 9 over 10, 9 over 10. So the moment you get a second iteration, if this combination repeats, then it will take the same steps as it did previously. So that is how a number starts repeating indefinitely, because we just use the same steps again and again. So we want to look for those steps. So we want to keep a list, a dictionary, a tuple. We want to keep a collection where we can check, has this combination been tried before? If this combination has been tried before, then the steps taken in that combination will be repeated again. And then if it's repeated again, it'll be repeated in the next step, and so on. Okay, so we start by creating an empty list called quotient num. Okay, you can call it anything. This is what I named it. So we updated it with all the new numerator and quotient pairs registered after the decimal point. Okay, so this will be a list inside a list. Okay, so what do I mean? Let us put a breakpoint in. Where do we do it? Let's do it there. Okay, now we want to run, and we want to take 1 divided by 3. All right, so there we create our empty list. Okay, so while num. Okay, so this line of code, while number. Okay, so our number is currently 1. Okay, so this while loop will stop executing the moment our number is 0. So if you just put an integer variable after a while, then that's just a shorthand way of saying it will stop executing once the number is 0. Once this number is 0. Okay, so we want to stop executing once our numerator is 0. All right. So then you'll see I also put in a lot of comments in this code. It's also to help you make a bit more sense of it. It might be very difficult to understand this program in a single class. We don't have a lot of time left. Okay, so I'm going to advise you to take a look at this on your own at home. Break this program down into steps as I showed in the beginning. If a line of code doesn't make sense, if there's too many going on in a single line, do it in separate steps. Okay, take that single line and break it up into more lines of code. All right, so you do it smaller steps. You know the saying, how do you eat an elephant? You do it bit by bit. So that is what we will be doing with a big program or difficult program like this. All right. Just a quick note also, I could not test this program on the, you'll see the evaluator is offline. It's been offline most of this week. So I'm going in faith, believing this program works. I tested it alongside the official solution. And I got the same results as the official solution. But I do not know all the test cases, so there might be a chance my program is slightly off in some cases. I will only know that once the evaluator is online again. So if there's any problems, I do ask for forgiveness in advance. Okay, so where was I now? Sorry. Okay, so we start by creating the empty list quotient num, and then we update it with all the new numerator and quotient pairs registered after the decimal point. Okay, so here you'll see. So this will be a list of lists. Okay, so you'll remember we can store items in a list, but then for every item we can also store an item in a list. We can store a list in a list. So we can say list index number 1 is also a list with indexes. All right, so this is more or less the approach we'll be taking because we want to store the pairs. You can also use something like a dictionary or a set in this example. A dictionary might also work. Then you can store the quotient with the quotient as the dictionary with the numerator as the value in that dictionary. That's also a way to do it. All right. I just use a list of lists. It's something I use often, so I understand it a bit better. Okay, so now we start with this while. So in case the remainder is equal to 0, there are no repeating decimals. So the moment our remainder is 0, then we can also exit. So therefore we don't need to add any parentheses, and we can break the while loop and return the result. Okay, that is just what I explained here. So when our numerator is 0. Okay, so our remainder is now we take our numerator and then modulus the denominator. Okay, so if the remainder is 0, then we just add then we take the results and we cast this to a string, so just that it prints easier. Okay, then we take the I with the index of -1. All right, so let's break this down. As I said previously, we want to store the quotient number pairs. Okay, so you'll see first we take the remainder with the modulus. So now we do 1 divided by 3. Okay, so you can see in PyCharm this neat little feature where it shows the currently assigned variable. All right, so first we have the remainder of 1. Okay, so if the remainder is 0, so this whole part gets skipped. All right, because that is not true in this case. So then as in the long division, where is that? So as in long division, you remember then you multiply the numerator with 10 for every decimal point. So we multiply it by 10 to get the next decimal. Okay, so we take the numerator. So we take the remainder, multiply it by 10, and we assign that to the numerator. Okay, and then after that, the quotient will be assigned the absolute value of the floor division of the numerator and the denominator. Oh, I'm sorry. Let me just quickly mute this group. Mute server. All right. I thought that was a question for a moment. Okay. So then after that, we assign this value to the quotient. Okay, you'll see this line. If the new numerator and quotient are not already in the list, we append them to the list. Okay, so as I mentioned here in this slide, we want to update the quotient number list with all the combinations of our numerators and quotients. Okay, so this is where we start storing them. Okay, so if this combination is not in quotient nums, then we can add it to our list of quotient nums. Okay, so now you'll see I take our list, quotient nums, and I append. You'll see these two values. So I append them as a list of lists. First I add the numerator, and then for the numerator, the quotient. So you'll see here in our debugging, because of our breakpoint, we added the value 10 as a numerator with the quotient of 3. Right. Yeah, you'll see here, there's a 10 and the 3 that has been added. Okay, so we're doing this so we can see repeating steps. So the moment we add a combination of 10 and 3 again, that means our steps will start repeating, so then it is a repeating decimal from that point on. Okay, so now we do this, we start from the top, alright, and now we append it the second time. So we saw now that this, the 1 divided by 3, that combination, or the 10-3 combination, is already in our list. Okay, so now we go on to the next place. Okay, so the next if function. Okay, so if the new numerator and quotient are already in the list, so that happened now. So we once again got the values of 10 and 3. So if that is already in the list, we break this execution and we prepare for the final result. So that means we now want to add, as the question states, let me go back to the question. We want to add the bracket. So now we've found the repeating decimal, because these steps will just be repeated ad infinitum. That means forever. So now we want to start by adding those brackets. Okay. So let me go back to the program. Okay. So we want to start preparing the final result. So we track we track the index position, so we can add the parentheses, the brackets, and so we can output it in the right place. Okay. So now this combination is in quotient numbers, so that means our steps will start repeating now. So now we take the index. So we take we create a new variable called index, and we assign it the value. We take the index of the quotient nums, and then you'll see of the combo we used. All right. So for every I in quotient nums up until the index, we create a new variable, and then we assign the string. Okay, so that means we go from the beginning, so from the beginning of the string up until the repeating decimal. Just before the repeating decimal, you'll see 1 before the repeating decimal, we add a bracket. Right, and then we go up until the end, and we add our final bracket. So let's take a look at what happens. Okay, so our line of code is currently here. This is where execution paused. Okay, so I get the index. We create the index. Okay, so you'll see the index is at value 0 because the it started immediately. All right. So then we take result, and we add our first bracket. Okay, and then we add the rest of the decimal. So for every decimal remaining, so there was only 1 because it was our repeating number was the first number, so then it is only 1 number, so we add the last bracket immediately, and then we break the execution and we return our result, and our result is, as you can see, 0.3. Let's try that again with another number. Let's take a look at one of the others. What was let's say 9 divided by 7. Let's take a look at what happens there. So let's debug this again. Let's say 9 divided by 7. Okay, so we stop at the same place again. So this will be, let me actually start from where we prepare our number once we found the repeating number. Okay, so I'm going to start here once we found our repeating number. Then I'm going to say 9 divided by 7. Alright, so now we found our combination. So you'll see here, our quotient nums list is now a lot longer because there's more numbers. You'll see in this example, the numbers, the decimal number 285714 repeats infinitely. So this combination of numbers will repeat forever. Okay, so now you'll see we have a lot bigger list. So it went up until it found the latest repeating one. Okay, so you'll see the numerator of 20 and the quotient of 2. So the numerator of 20 and the quotient of 2 was our first entry. Then we had all sorts of steps, but then it didn't get added again because you'll see our latest iteration found that the numerator is 20 and the quotient 2. So because we already have it in our list, we do not append it. So that means we found the repeating part. Okay, so everything after this will just be a repetition of this combination of steps. Okay, so this is a bit of a bigger combination. Okay, so now if we step into our code, we get the index. Okay, so we add the first bracket. Okay, so you'll see here in our result. So we have so up until this point, we added everything left of the decimal as we did here at the top. So we added one decimal point, and now we added our first bracket. Okay, so now we add every number in our decimal up until this point. So you'll see I had to step through it a few times now. So we added 2, 8, 5, 7, 1, 4. I think that is the entire range. Yes, 1, 4. We end there. Okay, so now we went through every number in our current quotient nums string. And then we add the final bracket, and we break and we return our result. Right. This is a difficult program. There might be quicker, easier solutions. I could not get my faster, shorter solutions to work. If you find a better way, please do share. I might be a bit embarrassed, but that will be awesome if you found a better way to get yours working. Mine is a bit convoluted. All right. And then for the final part, so you'll remember this entire thing is a function. So this will not run unless we call it. So I can actually hide this entire thing. So the user doesn't even have to see that monstrosity. So how do we call that code? So this is the final part. So first off, this is actually the start of the program. This whole function will not be called unless we actually call it in our program. Okay, so here is the start of our program. So I take two variables, the numerator and the denominator. I want to input them in a single line. Okay, so I map. You remember the map function. So then I execute a function on every iteration of something. So my input will give me actually give me a list that we split. So you'll see I use the split function. So then I can add a character where I want to split. So I want to split my function by the division symbol. So that means once I run this code, so I can enter, let's say, let me do a silly one, 44 divided by 45. So what happens here is I can do it in a single line, but my program will actually ignore this division because I'm entering it as a string. Okay, so it'll ignore this division. It'll return, it'll take the single line of input and it'll split it by this division symbol. So that means I get two strings. I get 44 and I get 45. So then I get 44 in numerator and 45 in denominator. And then in my function, you'll see I created two arguments. So I can add a numerator and a denominator. So then I just print the result of my function. So then I just run my function. I run this function with the arguments of the numerator and the denominator. This was a terrible program. I think some programmers would actually laugh at the solution, but it works. If it works, it's fine. All right. This might not make sense immediately, but please do take a look at it again afterwards. Break this program down and add breakpoints as I showed with the debug. Okay, I see our time is running out. Let me do a quick look at question 3. Here's also the full program. What I'm going to do is I'm going to copy this entire program. Yeah, definitely going to have to go through this again. I had to go through it a few times to understand. All right. I'm going to add this, copy this program into the chat. Okay. You'll see there. And then you can copy and you can paste this entire program into your PyCharm to see if it works, how it works, and you can break it up into parts. All right. So take a look at my solution. You'll see in the Friday classes channel. I think I should actually add this to the lecture material channel, or coding assistance. Let me do coding assistance. Just here at the top. Python. It's not supposed to work, is it not? Alright, there you go. You can copy this entire... Oh, just ignore the Python there at the top. I made a mistake now. Alright, I see Kylie is typing. Let me do a quick run through of solution number 2. Number 3, sorry. Okay, so for number 3, you had to create a word chain, or identify word chain. So a word chain is an ordering of a set of words, so that each word is exactly only one letter different from the previous word. Let me quickly just see this. That's a little scary, but I will definitely try. It was scary for me too. Do not worry. So a word chain, every letter can only differ by one. So for example, care, hair, cart. Okay. So you'll see in this entire chain, only the C in the first word differs from the H in the second word, and only the T at the end differs from the E in the second word. All right. So there can only be a one letter difference. The moment there's more letters differing, then it is not a word chain anymore. Let's take a look at here. Pat, butt, pet, buff, pot, rat, putt. So for example, rat and butt cannot be next to each other because they differ by 2 letters. So R is different from B and U is different from A. So these two cannot be next together. But this entire thing can be a word chain if it is ordered in such a way that every preceding letter is only one letter different. If each following word is only one letter different. All right. So we can enter this chain, and we can make a word chain out of it if we order them in such a way. Okay. So how do we do this? So first we want to get, I created a permutation function. Okay, so permutation means we want to see every combination possible. So let me show you, let me break this down into a, so I'm going to take this entire line of code. I'm going to, okay, oh, I did it here already. So this is a function that I wrote just so we can see every combination. So let me add, let's say bear. So if I run this code, oh, I gotta print it, permutations, and let me print this result. Okay, so you'll see, so we have the words cat, dog, bear. I want to see every combination. So the first combination is cat, dog, bear. The second combination is cat, bear, dog. Third combination is dog, cat, bear, cat, bear, cat, dog, bear, dog, cat. So with this little function, I can see all the combination of words. Okay, so that will be essential if we want to check how we can make a word chain. So we want to check every single combination of words. Okay, I see our time is getting short now. Let me show you in the slide. Okay, so in this slide, I took the entire permutations function and I broke it down step by step with a comment on what that does. Okay, so this is only the first part of the solution. Go take a look at this on your own. So I can get through the rest of it. If you have questions about the solution, we can go through it again next week. I don't want to keep you too long. I still want to assign the homework. Okay. So then I had a second function where I want to check if a chain is valid. So I want to check every word. So I start with a single combination, and I want to check every word, every combination, to see if it only differs by one letter. Okay. So you'll see here, if I created a for loop, so I'm checking for okay, a case. Let me explain it like this. Let's go back to our chain. Okay, so I'm calling it a case. Okay, so I have okay, so I create a string called solutions where I'm going to add every word that is a word chain from the previous word. So then in the end, I will have a chain of words. Okay, so all combinations, this is our permutation function we wrote. So this is how we see all the combination of words. Okay, so then we check for every case in the combinations. So a case is, this first part will be a case. If we look at this little permutation test we did, so cat, dog, bear, this will be case 1. Cat, bear, dog will be case 2, and so on. So then we check for every case, we run our function to see if it is a valid chain of words. Okay, so how this works is we take the case, for example, let's say cat, dog, bear, or let's take one of their examples actually, which was cat, care, hair, cart. Let me quickly do that so I can explain. Let's say care, hair, cart. So let's run this. Okay, so the first case will be care, hair, cart. So this entire combination is our first case. Okay, so now we want to see if every letter only differs by 1. So we first do a check. So we take the entire case, so that we take these 3 words. Then for every word, we start at the beginning of the word, or we start at the I, and we check is it the same as I minus 1. So I minus 1 meaning the previous words. Okay. So if it is not, then we return false. This means that this combination is not valid. Okay. So if it does not return false, now we can start counting the differences. Okay. So we want to keep it only one difference. So for example, between care and hair, there's only one letter different. The C in the beginning and the H in the beginning. Okay. So we have a counter basically to track the differences. And then we say for every letter in our range, in our case, we want to check the case. So you'll see here we have 2 indexes. So we take the first case, and then we do for this example, we do the first word. All right. And then in this one, we do another case with we check another case and also with another word. So now, if those words are not the same, if those letters are not the same, so we start at, for example, we start at E. You can actually put a breakpoint in there. Let's see. Let's add care, hair, cart. Okay, so at this point, you'll see we have care, hair, cart as our case. Okay. And then our case has three values, right? So the first word is care, second word hair, and then after that cart. So we start at I1 and J0. So that means we take a look at the first letter of the first word, right? And then we see from that the first letter differs. Okay, so H is different from C, so there we get our first difference. Okay, so we add it there as a 1. We run through the entire word, and we see that that is a valid case. Right. I see our time is our time is up now. I will go through the solution again if you have any questions on it, but I'm also going to copy this solution for you into, let me put it in Coding Assistance. So break this code down for you step by step as I explained, and then add other variables, the test variables as I showed earlier, if you do not understand a line. All right. Also quite a big program, this one, but everything is material we have done. There's nothing in this program you haven't done before. So every single line should make sense. Even in the bigger scheme of things where it is a bit difficult, you should be able to understand every separate line of code. Okay, so run through this with a breakpoint and try and understand every separate line. Okay, so now your homework. Okay, your homework is 2017 round 2. Okay, so the same on the Programming Olympiad website as we did previously. Let me quickly add that. So the Programming Olympiad, this website, you'll see under past papers, school rounds, 2017 round 2. All right. I will copy this link for you once again in the Friday class channel. Follow that link and that is your homework. I also want you, if you struggle with anything, what we've done in the past. So take a look at, you'll see on the Discord under lecture material, go through our classes we've done previously, look at the PowerPoints, and any class you struggled with, please send me an email by around Wednesday, so then we can do it in next week's class. I have covered everything I wanted to cover with you, so from this point forward, we'll be doing revision and practice. Okay, I will be giving you some difficult challenges, but it will help you grow as a programmer. All right. So that is it. I hope you can make sense of these programs. I found it difficult, but it is possible to do. It just takes a while to understand every part of the program. All right, our time is up a while ago already. I'm sorry for keeping you a bit later today, but I hope you have a good weekend. Please email me your questions, and I shall answer them next week in the class, and then we can do some revision. All right, good luck with the homework. It's also a round 2. Round 2 is always a bit more difficult than round 1. 2017's round 2 is, however, not as difficult as this round 2 was. This one was a beast. So next week should be a lot easier. All right. Have a wonderful weekend. Today was useful. I'm very glad, Keen. I'm glad if I could teach you something or show you some ways to program. All right. Programming can be quite difficult at times. I was pulling my hair out of my head, getting my solutions to work. But it did in the end. So break it down, try and make sense of my solutions. All right. See if you can do it on your own. If you can't do it on your own, that is perfectly fine. These are some next level questions. 2016's round 2 was infamously difficult. All right. Thank you, everybody, and have a good weekend. Goodbye.